Hi. In your note packets, please find this page. It's like Day 2 notes, 3 cases of restricted domain. The majority of the time when looking at functions, the domain is x can be any real number. But there are going to be times when we have restrictions on the domain, and these restrictions can be determined by looking at the equation. The first case is when we have a fraction, and the issue is that we can't have a denominator, can't have a 0 in the denominator. The way to find the domain is we'll set the denominator equal to 0, and then we solve for x. The notation will look like this, that the domain can be such that x cannot be whatever solution we got for x when we set the denominator equal to 0. We have 2 examples here. G of x is equal to 1 over 2x plus 6. It says to find the domain, and then we'll verify our answer using the graphing calculator. The denominator is 2x plus 6. 2x plus 6 is equal to 0. Solve for x. X is equal to 3. We label the domain with a capital D. X can be anything as long as x is not equal to negative 3. And that's how we write the domain of a function that is a fraction. Number 2, notice it's a parabola. We're going to take the quadratic x squared minus x minus 12 is equal to 0. Solving a quadratic means we factor it next. We have x plus 3, x minus 4, and we get the 2 roots of negative 3 and positive 4. Therefore, the domain looks like this, x such that x could be anything as long as x is not a negative 3 nor a positive 4. So that is the first case when we have a fraction. The second case, actually, with the graphing, with the fraction, notice what's going to happen when we graph these 2 functions. Actually, we're going to graph the first one, example number 1. And what happens is, let's go to our graphing calculator, and we go to our y equals, and clear out what's in there. We have 1 divided by, and if we don't use the n over d button, we need to put in parentheses around the denominator, 2x plus 6. And we close. I'm going to hit zoom standard to make sure we get back to our standard window. And notice that at negative 3, there's a blank line. There's nothing there. And we can verify that using the table of values that at negative 3, we do in fact have an error. So the function does not exist at negative 3. So with fractions, to show it graphically what's going on here, so I'm just going to redo what we did on top, that g of x is equal to 1 over 2x plus 6. And we got that the domain can be any number as long as it's not negative 3. So at negative 3 is this imaginary kind of invisible line that exists, and it's called an asymptote. And the asymptote, the way we graph it on paper, is going to be a dashed line. And it shows where the graph is getting closer and closer to that line, but never crosses it. So you have the definition right there. Imaginary line that a graph gets closer and closer, but never crosses it. To graph it, you have to graph it on paper, and we need to label it using the equation x equals negative 3. And then we'll sketch the other 2 parts of the graph. And notice that the part on the left gets closer to negative 3 but never touches it, and that the part on the right also gets closer to negative 3 but doesn't touch it. What we also want to make sure we know how to do is to describe the range. And the range for this graph, y is anything but it can't be. You notice that it never hits the x-axis, so y is never equal to 0. With fractions, set the denominator equal to 0. Solve for x, that'll be your domain. The graphic representation of it is you're going to use a dotted line to show the asymptote, label the asymptote with the equation of the line x equals -3, and then sketch other parts of the graph that you got from the graphing calculator. And you'll get used to sketching those curves the more that we do them. All right. On the back, we have the next case is when we have a radical. Y is equal to the square root of x. Now, to keep things real, the radicand has to be a positive. So the issue is that we can't take the square root of a negative number. So to find the domain, we set the radicand greater than or equal to 0 because we can take the square root of 0. We solve for x. And this is going to be our domain. So whatever we get for x is going to go inside the curly brackets for the domain. We'll do the same thing here. We'll do an example, and then we'll verify it using the graphing calculator. Y is equal to 3x minus 3. The stuff underneath the radical is 3x minus 3. We set it to greater than or equal to 0 because we want the radicand to be positive. Solve for x. X is greater than or equal to 1. Therefore, the domain is x such that x is greater than 1. And for first going to sketch the graph before we state the range. So on your homework, when it asks to state the range, you need to sketch the graph first. So let's go to our y equals, clear out the previous example. Second square root, 3x minus 3. All right, that was the second function. Second square root, 3x minus 3. Press graph. And this radical got shifted to the right one. So notice how it does match. So when we do a sketch, a nice, neat sketch, at 1, it starts and it kind of swishes out like the top half of a parabola, sideways parabola. So when we go back to the graphing calculator, there's a couple ways we can verify that. We can go to the table of values. Notice we have all the error messages. At 1, it does equal 0. It does exist. But anything less than 1, there is an error. And we can also click on, or press trace. And we're on the graph. Notice it didn't exist until our x value was 1 or greater than 1. Once we have the graph, we now can describe the range. And the range here, y can be anything as long as, if you look at the graph, notice y are positive numbers. They can equal 0. We say positive in math by setting them greater than 0. And again, you'll get this after you sketch the graph. So this is the second case that we need to keep an eye out. That when we see a radical in our function, we look at the radicand, set it greater than 0, solve for x. That's our domain. Notice how that x is greater than 1 is exactly what our domain is. Sketch next. Once we sketch the graph, we can go back and determine the range, describe the range. The last case is a combination of the two, where we have 1 over the square root of x. The issue is there are actually two issues. One, just like in the first issue, we can't have a 0 in the denominator. And the second issue, which is what we just talked about, case number 2, is the stuff underneath the radical, the radicand, must be positive. So this one is very similar to the previous one. The only difference is that we can't have it equal to 0. So the radicand has to be strictly greater than 0. Has to be positive. Solve for x. And again, the domain will be x such that, and then whatever inequality we get there is going to be in their domain. We'll do the same thing for number 4. F of x is given to us as the fraction 1 over the square root of 6 minus x. Take the radicand of 6 minus x, set it greater than 0. Solving for x, you have a couple of choices. You can add x to both sides, and then you get an equality, or you can subtract 6 and then multiply by a -1. Either way, you should get that x is less than 6, and that should make sense because the numbers underneath the radical have to be positive, and they can't equal 0. So we subtract numbers that are less than 6 in order to maintain that the answer is positive. We can describe the domain as x such that x is less than 6. We have to do the range after we get the sketch, so we go back to the graphing calculator, go to your y equals, clear out the previous example. The alpha F1 is your n over d button. If you have that on your calculator, you can press the n over d button, and you see that it's in fraction form. So it's just another way of writing it. That way you don't have to put parentheses. We have the square root of 6 minus x. Press graph. And we have another kind of a graph, a swoosh there. And notice what's happening at 6. If we go to the table of values, it looks like that at 6, there's going to be an asymptote because it's getting closer and closer to 6, but it's not actually touching 6. At 5, we have the 0.51, and then it's getting bigger very quickly, but it's not ever going to touch x equals 6. Fractions, if they have an expression in the denominator with an x, you're going to see asymptotes. In your note packet, the next page is a day 2 classwork, investigating domains. You will work with your partner, find the domain algebraically like we did in our notes. Using your graphing calculator, graph the function, sketch and verify. Please label your asymptotes and make sure you have the arrow tips. And then after you've sketched it, please describe the range.